A person whose shoes have leather heels is walking on a wooden floor. Find the maximum angle the forward leg make with the vertical in order that the heel not slip on the floor. How is this angle affected if the floor is wet, which reduces the coefficient of static friction? Now, for the static friction, the coefficient of static friction between leather and wood, if you have leather and wood, mu s, okay, leather on wood, mu s equals 0.5. So let's try to draw the figure. So if this is our wooden floor, then the heel, so for example, this is the forward leg. No? So the angle that we are talking about, find the maximum angle the forward leg make with the vertical in order that the heel not slip on the floor, which means that this is the vertical that we are talking about, and the angle referred in the problem is this. What should be the measure of that angle so that the person walking will not slip on the floor? Now, when you step at a certain angle, there is a force applied. So this force is in this direction. Okay, that is the applied force. Let's say that that applied force is F. Now that applied force also makes, if this angle is theta, this angle theta is the angle formed by the leg with the vertical, then this force here is just, an extension of this leg here, of the angle of this leg, which means that that applied force also makes an angle theta with the vertical. Now that applied force has vertical and horizontal components. So the vertical component, this is the vertical component of the applied force. Let's make a Fx, and this is the horizontal component, Fx, that's Fy rather. This is Fy, and let's make this Fx. Okay? Now what are the other forces involved? Now take note that this is our surface. So the surface is horizontal, and the normal force is perpendicular to the surface, which means that the normal force is opposite Fy, right? So the normal force is directed upward. This is our Fn. And there is a frictional force, the static friction, directed towards the left, Fs. So it's not moving, the heel will not slip, so making an equation, the first equation that we can make, looking at the horizontal forces, so Fx, net force is 0. Net force is 0. So the force directed towards the right is Fx, directed towards the left is Fs. And so because this is 0, 0 equals Fx minus Fs. So Fx is simply equal to Fs. Fs, or the static friction. But this Fx, take note looking at this is the angle theta here, which means that this is the horizontal component of the angle theta. This is the vertical component of the angle theta for the force. This is the horizontal component of force F because this is the angle that we are considering. And Fx here is the vertical component of F looking at this angle. So therefore, Fx is F sine of theta. And Fs is mu s Fn. Now, what is Fn equal to? So for the vertical forces, remember that the normal force is not always equal to the weight because it depends upon the angle. So for the vertical forces, net force is equal to 0. All the upward forces, so the upward force is the normal force, and the downward force is the horizontal component of F, which is Fy. So the net force is 0, so Fn minus Fy. So Fn equals Fy, and that Fy is equal to, that's the horizontal component of F. So that is F cosine theta. So we can substitute this Fn here in our first equation. So F sine of theta equals mu s. Fn is F cosine of theta. So we can cancel out F. So sine theta equals mu s cosine theta. Or mu s cosine theta equals sine theta. Mu s equals, okay, let's just not So sine theta equals mu s cosine theta, where sine theta over cosine theta equals mu s. But sine over cosine is tangent, so tangent theta equals mu s. So the angle here must be arctangent of mu s. Mu s between, or the coefficient of static friction of leather on wood is 0.5, so that is the arctangent of 0.5. So the angle theta, the maximum angle theta that the forward leg will make with the vertical in order that the heel will not slip on the floor is arctangent of 0.5, or that is 26.5651 degrees, the angle with the vertical. So how is this angle affected if the floor is wet, which reduces the coefficient of static friction? So from this relationship, what if, diba, if the angle here, or if the coefficient of static friction here would be lesser now than 1.5, because this is the maximum angle na ng theta. So dapat if mo decrease ang coefficient of static friction, then the angle should also be decreasing so that we will not slip on the floor. The more wet, the lesser the coefficient of static friction, then the lesser the angle should be made with the vertical.